My name is Ian Pearson. I'm an applications engineer with Microchip, and I also look after the wireless and IoT solutions group in Europe. Today we're going to look at the SAM R34 X Pro development kit for LoRa WAN. This is an evaluation board to help customers develop with both the new SAM R34 SIP, which is a microcontroller and a radio combined in a single package, and it also allows you to develop and connect to a LoRa WAN system. LoRa WAN is a long-range, low-power, wide-area network. It gives huge distances for very small packets of data, allowing us to connect sensors and actuators to a network and allow interaction across the internet, accumulation of data, and control of items. So this particular board contains the main component, and that's under the shield, which is the SAM R34 SIP, and all of the RF circuitry to provide us with our system design. This system is also designed to allow us to pass certifications such as RED, FCC, and others, and that's been done based on this antenna. So this is our system that we've put through certification. For a customer, you have to take this end product and put it in your design. That will require some slight modifications, but we do know the system will pass and is certifiable. If we turn the device over, it comes with an onboard debugger, which also provides things like current measurement. It provides a USB interface so we can run a terminal interface to the device so we can get information in and out and interact with our board. And some expansion interfaces. These can allow us to put on things like sensors, or they may also allow us to plug on there a device which provides the security chip. Also on the board is a backup battery. LoRa WAN systems for the main part will be asleep. They will make sensor measurements, they will accumulate them, and then they will make the decision to send them. They're a very low bandwidth system, so they don't need to be on the radio all the time. Most of what they do will be in sleep. So this is a critical part of the system, allowing the device to run lowest power operation and run the real-time clock. So this particular board can run many demos. The most crucial one is to be able to connect to the network. So we run up an example project in Atmel Studio, we connect through our USB interface, and we program the board through the debugger. That will allow us to register this particular device with some key parameters that would be crucially the MAC address of the board, which gives it a unique identifier in the world. We register that with a provider such as the Things Network, and that allows us to get some IDs and some security information to register this particular board on their system. Once we've done that, we do a join, and the board can join the system, and you will then see the board interact. The example program will do things then like allow a button to be pressed, it will take sensor information, allow text to be pressed to do certain operations. Then we can get deeper if we wish to, and we can start adding more sensors. So lots of information can be passed up to the network to confirm we have both the connection and the ability to pass information. The SAM R34 X Pro development kit, targeting the SAM R34 SIP for development of LoRa WAN low power networks. For more information, see the links below.